what's going on, guys? Today we're going to start this video with right triangle trigonometry. This is sort of a review from geometry when you did trig and geometry. But anyway, man, hey, I hope it helps. Let's get started. Trigonometry right here, guys. We have triangle measure. Alright, we will be using right triangles and their sides and angle measures to solve problems. We will use the Greek letter theta to represent an unknown angle value. So theta is our variable. If you remember in algebra, you use x to represent a number. Alright, like hypothetically x equals 4. Well, right here we're going to use theta to represent an angle value. So theta equals 47 degrees. Alright. This is hypothetical, all right? So, right here, it says, what are the 6 trig functions? Well, I went ahead and put them here for you so we can save a little time. Right here, theta is our angle. All right, this is the angle we're looking for. All right, so if I wanted to find sine of this angle right here where theta is, all right, sine of theta would be opposite side over hypotenuse. All right, the hypotenuse is always the longest side on a triangle. So again, the hypotenuse is the longest side of a triangle. Cosine would be the adjacent side. This is the adjacent side of a right triangle. All right, over the hypotenuse. Okay. Tangent is the opposite side over the adjacent side. Cosecant is the inverse of sine, so you would just flip this. All right, hypotenuse over opposite. Secant is the inverse of cosine. All right, so you would just flip that. All right, whatever you had here, you would just flip it. All right, invert it. So hypotenuse over adjacent, and cotangent is the inverse of tangent. Okay, so now we're going to use that information. It says find the exact value of all 6 trigonometric functions. So look, we have sine. All right, sine, here's theta. All right, if you remember, sine is opposite over hypotenuse. So opposite is 9. And then hypotenuse is the longest leg here. All right, matter of fact, I'm going to label all of this. This is going to be O for opposite. This is going to be A for adjacent, and this will be H for hypotenuse. All right, so opposite over hypotenuse. Cosine is adjacent over hypotenuse, so 12 over 15. Oh, by the way, we can reduce this. Both of those are divisible by 3. So we have 3 over 5. This one reduces by 3, so 4 over 5. Secant, I'm sorry. I'm jumping ahead of myself. Tangent. All right, tangent would be opposite over adjacent. See, opposite over adjacent. So you have 9 over 12, which is 3 over 4 when you reduce it. Now, cosecant, the inverse of sine, you can just flip it, guys. 5 over 3. But remember, it's hypotenuse over opposite. So 15 over 3 reduces to 5/3. 15 over 9, reduces to 5/3. Secant is the inverse of cosine. So we'll have 5/4. And tangent inverse is cotangent. So we'll have 4/3. That is all 6 trigonometric functions. All right. These right here, these values. Sine, cosine, tangent, cosecant, secant, cotangent, okay? All right, I have another example for you. This is a U-try. All right, actually, I'm gonna leave that there. That'll be good practice. The thing to remember is, actually, to give you a little hint if you're looking at the video, here's theta. All right, this is theta. So, this would be opposite. This is the longest side. So this will be hypotenuse, and this is adjacent. All right. So there you go. Find sine. All right. Find sine all the 6 trig functions. All right. For this one, it says you can also find all 6 trig values given just a ratio. All right. So check this out. All right. What we got to do is step 1, you're going to draw a triangle. All right. So all this is positive, 3/7. I don't want to confuse you. All right. But we can just draw a triangle. Oops. We're going to just draw a triangle. So here we go. Let me see if I got a shape on here. Yep, I do. All right, it only goes one way. Actually, I know what to do. All right, so we have a triangle. So I'm going to call this angle theta. Oops, I'm going to call this angle theta right here. There we go. That's going to be theta. All right. So if you remember looking back at our chart, cosine of theta, cosine is adjacent over hypotenuse. All right. I'm going to write it out for you. Adjacent over hypotenuse. So if this is theta, the longest side is the hypotenuse. All right. And then the adjacent leg would be right here. This is the opposite side, right? So this is adjacent. So now I need to, step 2, solve for the missing side. Well, to do that, we use what's called Pythagorean theorem. Now, if you remember, Pythagorean theorem was a squared plus b squared equals c squared. All right. So we have one side and we have the hypotenuse. All right. So we have side, a side, which we don't know. All right. And we have the hypotenuse. So to solve for the missing side, we're going to use what we have here. So we're going to go a squared, we'll say 3 squared plus b squared, because we don't know what this side is yet. This is what we don't know right there, right? Equals 7 squared, okay? So what we're going to do is solve this. So we have 3 squared is 9 plus b squared equals 49. And then we subtract 9 on both sides. So b squared equals 40. And then we've got to solve this and get rid of this square. So to undo that, we take the square root on both sides. And we end up with b equal, because the square and the square root will cancel. And the square root of 40 becomes square root of 4 times, all right, so the square root of 4 times the square root of 10. All right, and the reason I did this is so I can simplify this. The square root of 4 is 2. The square root of 10 is still the square root of 2. All right, so we now found b, or in this case, we found this missing side right here. So we now know what O is. All right, it is 2 square root of 10. So we have O, we have H, good night, H, and we have A, adjacent, okay? So now, given that information, we can find the remaining 5 ratios. All right, so we have, let's see here. Well, you know what? Well, here, let's write it out. Sine. Sine is opposite over hypotenuse. So 2 square root of 10 over 7. All right, we know what cosine is. Cosine was 3 over 7. Tangent. Tangent is going to be opposite over adjacent. Now, cosecant. Remember, cosecant is the inverse of sine. So we need to flip this. 7 over 2 square root of 10. But one thing is, you have to remember, this needs to be rationalized. All right, you cannot have the radical at the bottom. All right, so to do that, move your radical to the top. All right, keep the number from the radical under the radical. Oops, 10. I'm thinking about the answer. Keep that at the bottom. Move the radical to the top, but keep the actual number down below. So that's 7 radical 10 over 20. All right, that's cosecant. Secant, same thing. It's the inverse of this, so flip it. And then cotangent. Right here, we gotta flip it. 3 over 2 radical 10. But again, you can't have the radical here. So move the radical to the top. 3 radical 10. And then multiply the two numbers. 20. So 3 radical 10 over 20. So those are all our, I know it's a mess right here, but those are all our 6 trig identities, okay? Right here, just to kind of get you started, you have a triangle. Oops. You have a triangle, then there's theta, and tangent, if you remember, I'm just gonna get you started. Tangent is opposite over adjacent. So opposite, adjacent, use Pythagorean theorem to find your hypotenuse. Alright, we don't know what that is, okay? Alright, let's continue. Right here in this chart, alright, this chart right here basically represents special right triangles. Alright, because this is a 30, 60, 90 triangle. 30, 60, 90. Alright, this one right here is a 45, 45, 90 triangle. Alright, so their measures are specific rules. Alright, and these are the angle measures. These are the side lengths every time. Alright, every single time. But anyway though, I'm gonna go ahead and skip down here. Solving for missing trig, using trig ratios. Guys, you're gonna use the same ratios you've been using, and then you're gonna just turn this into an algebra problem. Alright, so if we look, right, I need to find the value of x. Well, let's identify. Alright, let's label the parts of our triangle. We have our angle, so that's theta. Alright, this is theta. We have opposite. We have hypotenuse. Well, we don't know what that is, but we do have x right here, which is adjacent. So now you got to ask yourself, what trig function, okay, what trig function would be opposite and adjacent? Opposite and adjacent. Well, if we go back to our chart, let me go back to it. Opposite and adjacent. Opposite and adjacent tangent. Okay, tangent right there. So what we do is, let me go back to that problem. We're going to use that equation that we just saw, that it said tangent of theta equals opposite over adjacent. So we know what theta is. Theta is 47 degrees. So tangent of 47 degrees equals opposite, which is 26, over adjacent, which is x. We don't know. Now, we can solve this. We can very well solve this. Okay? I'm going to punch this into my calculator real quick. Tangent of 47 degrees. Alright. First off, I'm just going to make sure I'm in the right mode. I'm in radians. I need to be in degrees. There we go. Because I'm dealing with a degree. Alright. Tangent of 47 degrees. And your calculator does it for you. No problem. Right there. There's tangent of 47 degrees. Alright. 1.07. But for the sake of doing this, alright, here's what I'm going to do. I'm going to isolate x. How I isolate x is I'm going to multiply by x on both sides. Alright. So x tangent of 47 equals 26. Now I'm going to divide by tangent of 47 on both sides. So x equals 26 divided by the tangent of 47. Now, I'm doing this because I want a precise answer, all right? You could do it, and I'm going to show you. If you want 26 divided by 1.07, all right, we should have about the same answer, so let's have a look. If I did 26 divided by 1.07, all right, gave us that, but I'm going to do the exact value, 26 divided by tangent 47. I just want to see how close it is. All right, so you see that right there? So you want to be precise. All right, 27.04. So 27.04. 27.04. All right, that's too far. It's too differential. Okay. Oh, you know what it is? I see what it is. Look, I put 29. Look at that mistake right there. Let's go 26 divided by tangent of 47. All right, this should be a little closer. Yeah, there we go. So 24.2, 24.3, awesome. Awesome, so disregard this one. We don't even want to look at that one, right? 24.2, or 24.3, 24.2. All right, so cool. X would be 24.2. All right, so now, here you go. You give it a try, all right? Just to set you up here, if you are looking at the video, find the value of X. All right, we have our theta, we have opposite, and we have hypotenuse. So if you remember, opposite over hypotenuse, that's going to be sine. Sine of theta equals opposite over hypotenuse. So you'll set this up and solve for X, okay? All right, right here, when you need to solve for a missing angle, when you need to solve for a missing angle, notice the other problem, we were looking for a missing side. Here we're looking for a missing angle. All right, and it says we use inverse trig functions. Inverse trig functions. So tangent of theta equals opposite over adjacent, or tangent inverse equals opposite over adjacent. All right, or theta equals tangent inverse opposite over adjacent. All right, so here's what I mean. Here's theta. I don't know what theta is, but if I look at my right triangle, theta, here's opposite, right? This is the longest side, so that's my hypotenuse. And this is my adjacent leg, okay? So what identity uses adjacent over hypotenuse? Adjacent and hypotenuse right there, cosine. Okay? Adjacent and hypotenuse. So let me go back. So we have cosine. Cosine of theta equals adjacent over hypotenuse. So in this case, we have cosine of theta, we don't know what this is, equals 14 over 16. So I can't take the cosine of theta. I can't punch theta in my calculator and get an answer because it's a variable. But what I can do is rewrite this. All right, I need to undo cosine. So to undo this, what I'm going to use is this inverse. All right, I'm going to use this inverse. So I'm going to move cosine onto this side. So I have theta by itself equal to the inverse of cosine. See that? It's no longer just cosine, it's now the inverse of 14 over 16, like that. All right, that is what we can punch into our calculator. All right, so I go back to my calculator. Right there. All right. And we want the inverse of cosine. All right. So I'm going to press, see how this is cosine? There's the inverse button right there. So we press second cosine. And we want 14 divided by 16. All right, and this is going to give us our angle measure, 28.95 degrees. So we're going to say 28.95, or was it 28.95? I'm not tripping. About 29 degrees. We'll say about 29 degrees. All right, 29 degrees. Okay, 29 degrees. Okay. So again, I can't take the cosine of a theta. Just like right here, I can't take tan of theta. I don't know what theta is, but I have the other side of the equation, right? Well, we're going to move it to the other side and take the inverse. Okay, I hope that helps. There's a U try right here. All right, look at what you have. You have opposite, you have adjacent, and then the longest side is hypotenuse. All right, but we don't have that, but I don't need it. All you do is go, okay, which trig identity is adjacent and hypotenuse? All right, so you look at the three, I guess, parent functions: tangent, cosine, and sine. All right, one of those three is adjacent and opposite. So when I look at it again, let me go back to my chart. One of those three, right? The tangent, opposite, and adjacent is what we have. I don't have the hypotenuse, so I can't use those two. So you set it up. We said tangent. So tangent of theta equals opposite over adjacent. So I'll let you solve this. Okay, remember, I can't take tangent of theta. So I'm going to move that to the other side and use the inverse, okay? All right, so you finish the rest, okay? All right, it says, for this next example here, when you are asked to solve a right triangle, you are finding the measures of both sides and angles. So let's see, we need to find, what do we need to find right here? We need to find this angle. We need to find this side and this side. So I'm going to do one of these, and then I'll let you do the other. Okay, for this one, the angle theta is fine. I can find theta. Remember, a triangle has a sum of 180. All right, all triangle, if you add up all three angles, is 180. Okay, so what we have here is, that's a right triangle, so that's 90. All right, that's 63 degrees. All right, so altogether, that's 153. If I do 180 minus 153, I get 27. So this angle measure right here is 27 degrees. Now I need to find my adjacent and my hypotenuse, okay? Well, we can use angles, all right? Or we can use this one side to find these sides. And here's what we can do. All right, opposite, or A, I said A, I'm sorry, this is not, that's adjacent. This is the opposite side, so I'm going to put an O there so I know. I need to find this opposite side right here. All right, well, I know, and I can use any one of these. All right, well, here, I'll use this one. I'll tell you what. I'll use this side right here, opposite over adjacent. How about that? Opposite, adjacent. So using 63 degrees, we know that opposite adjacent is going to be tangent. So tangent of 63 equals opposite 200 over adjacent, which we don't know what that is. So when we solve this, remember, you can just swap these two, right? You multiply by A on both sides, right? And then divide by tangent 63. All right, so we end up with A equal to 200 over tangent of 63, which we can solve. 200 divided by tangent of 63. 101.9. So we know that side length right here, A, is 101.9. 101.9. Okay. And then we do the same thing. Right here we have hypotenuse. And we have opposite. So hypotenuse and opposite would be sine. So sine of 63, I'm using the same angle, opposite, hypotenuse. And the reason, guys, I'm not doing the inverse again is because I have an angle measure. I know what theta is. I'm using this one. All right. I'm using this one right here. Let me make sure that's clear. So sine is opposite, which we have, 200, over hypotenuse, which we don't know. Again, right here, we can just swap those, right? So h equals 200 all over sine of 63, which we can solve. Oops, wrong button. Calculate is what I want. 200 divided by sine of 63. All right, 224.46 or 224.5. All right. So this is 27. This is 224.5. And this is 101.9. All right, so we just solved that whole triangle, okay? I'm gonna actually stop this video right here. Yeah, because it's about 27 minutes now. Hey, I hope this helps, and I will catch you later. Peace.